Hi, and we're back with part 2 of our analysis of the ballistic apparatus. Last time we shot the ball against this mass and we calculated the velocity of the ball using law of conservation of momentum and law of conservation of energy. This time we're actually going to shoot it and test the velocity that we got by using kinematic equations. So here we go, the ball is already loaded. As it shoots, it hits the floor at about this location. Using kinematic equations, it is your job to estimate approximately where this ball hit and measure the displacement in the x direction from its original position over here inside the barrel. It is also important for you to measure the displacement in the y direction from the barrel down to the ground. You can do these measurements by various strategies, by measuring to the edge of the table and using rulers in a special way such that you get correct estimations for distance. Now let's look at the calculations. As I said, here's a diagram of how we launched the ball. Basically, we are going to look at the movement in the x direction and in the y direction. Over here, in the y direction, you know that gravity is 9.8. We know that the initial velocity in the y direction was 0. It started at 0 and fell down. And we are measuring the displacements. We're going to calculate by using two equations. We're going to find time using this equation here. And then we're going to find the velocity in the x direction using that equation there. For time, we just plug in the numbers for distance. We know the initial velocity in the y direction was 0, and then we find time is 0.45 seconds to reach the ground. Vx is 1.8 meters divided by the time. We get a velocity of 4 meters per second. Comparing this with what we got initially using our law of conservation momentum calculations, which was 3.71 meters per second, our percent difference is 7.6%. So we are relatively close in percentage. We can be very sure that we can find the velocity both by using the original calculations and using these calculations as well.